Hi, this is Alex from devstories.eu. Databricks, episode 9 of 15. If your nightly data processing relies on a chain of independent cron schedules, you're essentially hoping the previous step finished in time. You are flying blind. To stop silent failures and guarantee execution order, you need master orchestration with Lakeflow Jobs. First, a quick distinction. Lakeflow pipelines handle data dependencies down at the table level. Lakeflow Jobs, which we are focusing on now, orchestrate tasks at the macro level. Think of pipelines moving data inside the warehouse, while jobs string together notebooks, Python scripts, and machine learning models into a larger workflow. A job in Databricks is the overarching container for your orchestration. Inside that container, you define multiple tasks. A task is a single isolated unit of work. It could be executing a Databricks notebook, submitting a Spark application, running a dbt project, or firing off a SQL query. By linking these tasks together, you build a graph of execution, where one task only begins when its specific prerequisites complete successfully. Let us walk through a practical scenario to see how control flow handles reliability. You have a daily process that ingests raw data, checks its quality, transforms it, and alerts the team if something goes wrong. You start by defining an ingestion task. Next, you link a data quality task that runs strictly after the ingestion finishes. Here's the key insight. Instead of writing custom error handling inside your Python code to decide what happens next, you use native job control flow. You add an if-else condition task immediately after the quality check. The condition evaluates a variable returned by your data check task. If the data is clean, the job follows the if branch and triggers your downstream transformation task. If the data is corrupted, the job takes the else branch and triggers a webhook task that pings a Slack channel. You also manage state using run if task conditions. You can configure an alerting task to execute only if the previous task outright failed, while the rest of the pipeline safely halts. This prevents the classic silent failure cascade, where a broken ingestion step silently triggers a machine learning model to train on completely empty tables. To initiate this workflow, you apply a trigger. Jobs can run on demand, on a traditional scheduled interval, or continuously. They can also execute based on an event, such as a new file arriving in an external cloud storage bucket. Once triggered, Databricks provides built-in observability. You don't have to guess where a failure occurred. The platform records a complete run history with a metrics view, showing you exactly which tasks succeeded, which tasks stalled, and how long each step took. You can configure job-level or task-level notifications to send automated emails or webhooks the moment an execution state changes. The true value of this orchestration model is shifting failure handling out of your individual scripts and into the platform infrastructure, ensuring your system knows exactly how to route execution when things inevitably break. That's all for this one. Thanks for listening, and keep building.